Okay, here's an early attempt at attempting to recreate this. I know from experience that I need to initialize something. I know that I'm going to need to have two things, the previous and the current. And it's a good idea to start the previous at something, and that would correspond to B3 in the Excel. So let's have the previous triangular number be equal to 0. Then I'm going to list them from 0 through 5, and the current tri number is 0 times 0 plus 1 divided by 2, which I think comes out to 0. So then my square number equals the previous one, which is 0, plus the current one, which is 0, so the square of 0 is 0. Makes sense. And then we have this rather complex output here. Let's take a look at that. For a side of 0, comma, previous trinum of 0, and current of 0 is 0. I did construct this one phrase at a time. I didn't worry about the accuracy of the output. I just worried about getting it to show up correctly. I'm happy to say it actually did each time. Okay, when we run this, however, we see that we get the correct triangular number for side of 1. The current triangular number is 1. It's 3, 6, 10, and 15. But we aren't getting the correct square number. Let's see if we can figure out why. Back to the Excel. When I'm adding triangular number, I'm getting the new one here. I'm getting the 1, let's see, the 1, 3, 6, 10, and 15. But when I'm adding previous triangular number, it's always equal to 0. So somewhere along the line, I need to get a different value into prev trinum. And there are actually 1, 2, 3 different places you could put this. To me, it makes the most sense to do it after we've done the output. We're done with everything. We can go on to the next item. So what we're doing now is sort of swapping. We're putting the current triangular number into the previous one. So when we go around the loop the next time, we will come up with our new number. Let's see how it turns out when we run it. Yes, for side of 1, the square is 1. For side of 2, the square is 4, etc. So we've proved our algorithm that 2 consecutive triangular numbers add up to a square. The principle here is that in the loop we move the current one to the previous one. This is what you're going to need to know for a number of your optional exercises that follow. Hope you do those exercises, though. It's great fun thinking these through. Bye.